All right, algebra lesson 4-13, example number 1, graphing inequalities. So remember, this is just like graphing regular lines. So the first thing we need to start with is getting that y isolated so I can determine what my slope and my y-intercept are. All right, so I'm going to start by getting that y isolated by minusing the 3x to both sides. Negative 2y is greater than or equal to negative 3x plus 2. And then my last step to get that y by itself is divide all pieces by the negative 2. And this is the first thing that I want to bring up here, is that in this step, we are dividing by a negative 2, which requires us to flip the inequality. Jeez Louise. Because we divided by negative 2. So, y is no longer greater than or equal to, but less than or equal to. The 3 and the negative 3 and the negative 2 cancel to be positive. 3/2 x minus 1. Oh my gosh, I just want to finish these so bad so I can eat some breakfast. All right, so that gives me the information I need in order to graph this fabulous thing. I have a slope, or an m value, of 3/2, which is my up and over, remember that rise and run. And my b value is a y-intercept of negative 1. So starting at negative 1 on the y-axis, and then I turned the heater on and now I like it. And now my slope tells me up 3 and over 2. So up 1, 2, 1, 2, 3 over 2. 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 Okay. Nope, I did that last point wrong. 1, 2, 3 over 2. All right, so now before you make the line, stop and check to make sure if you get a dashed or a solid line. Remember, the not or equal to's. I am just failing at life right now. If it has an or equal to, it gets a solid line. If not, then it's a dashed line. In this situation, we have an or equal to going on, so we're going to get a solid line. I like to make a note of that to begin with, because then if you forget to make the line solid or dashed, it will, you've proved that you already know that. So a solid line, we're just going to go ahead and connect those dots as I normally would. Again, you're using a ruler, making sure it's straight. And so now this is the shading part. This is the tricky part, really. If you read that inequality, it says that y is less than or equal to the line, right? That's what that 3/2 x minus 1, that's the line. So y is less than or equal to that line. Well, if you put your finger on that line, where do the y values get smaller? Do they get smaller above the line or below the line? Naturally, they get smaller below or under the line. So I'm going to shade underneath. And when you're doing your shading, make sure that your shading starts from your line and extends all the way through the graph. Also, make sure that you're not scribbling, because we still need to be able to see if there's points in here and stuff. So shading, something like that. You can label it with an S for solution set, because what this means is that any point inside this shaded area is a solution. So it's asking me, is a point on the line a solution? Well, that depends. Did we have a dotted line or did we have a solid line? Do we have a or equal to inequality or just a regular one? We have a solid line, which means we have an or equal to, which means points on the line are a solution. So is a point on the line a solution? Yes, because it's a solid line from the less than or equal to inequality. Which means that any point on or in the shaded area is a solution here. Okay, we'll look at the next ones afterwards.